All right, so final exam semester 2 review, day number 4. So we only have one more day after this to finish off the 50 questions. So for number 31, it says approximate the solution using a calculator. Now, if you guys recall, I told you some of your calculators, the newer ones, you can actually do this by literally pressing your log button, putting the base of 5 and then a 16, and it'll give you your answer. But some of you guys don't have the newer calculators, and if you don't have those newer calculators, you can't do this problem by just pressing a log, putting the base, and then a 16. So you have to use the change of base formula, okay? So a change of base formula looks like this. Log base b of a is log of a divided by log of b, okay? So if you have to change the base, if your calculator cannot do this problem just straightforward, then this is what you're going to have to do. So for me, I'm going to write log of 16 over log of 5. Notice it is a log base 10, and the reason why we use log base 10 is because calculators, all calculators, can do log base 10. So let me just put that into a calculator. It's probably going to cover up the problem, but it's okay. It's log of 16 over log of 5. So log of 16 divided by log of 5. That's 1.7227. So I'll just put 1.72. So this is approximately 1.72. And by the way, this calculator that I used, this one right here, this one can't do log base 5. It doesn't know how. Okay? So I have to do a change of base on it. Even though it's, like, I guess you could say high tech, right? But it doesn't do it. Some of the smaller calculators can, like those black ones that I had, and I think those gray ones that I have as well can do them. But yeah, some can, some can't. All right. Rewrite as a logarithm. Okay? So there is a definition that says log base b of x equals y implies, or I guess we could put the arrow in both directions because you can actually move in both directions. It says that implies b to the y equal to x. Okay? So what we have is the right side, and they want us to go left. Okay? So notice the b is 4, the 3 is y, and the 64 is your x. Right? According to that right side, b to the y equals x. So 4 to the third equals 64. B would be 4, 3 would be y, and 64 would be x. So all I have to do is write down my equation. Log of b, which is 4, of x, which is 64, equals to y, which is 3. And this is your answer right here. I just rewrote it as a log. Okay, so just rewriting it as a log. Copy. All right, now rewrite as an exponential. Okay, rewrite this as an exponential. So, using the same little equation, right? Log base b of x equals to y becomes b to the y equal to x. So, notice my b term is the 5. The 25 is my x term. And the 2 is my y term, right? I'm looking at this and assigning my values to that. Okay? So if that's the case, then b to the y is 5 squared equal to 25. And that's all you got to do for that. So no calculation, just rewriting. Okay, you're just rewriting the problem. So again, make sure you write that little equation on the right side, that green one, right? That shows you this is how you go from left to right or right to left. Right? Assign your values and just kind of write down the problem. All right. So this one might be a little tricky, but you know, nothing too terrible, I hope. Okay? They just want us to simplify. So, x plus 2 over x divided by 3x over x minus 1. Okay? But remember, we don't divide fractions, we multiply by reciprocals. So I'm going to write x plus 2 over x times x minus 1 over 3x. And now I'm going to multiply, okay? I'm going to multiply across. The bottom, we'll do that first because that's going to be easier. X times 3x is 3x squared. Okay? So that's 3x squared. On the top, I'm going to have to FOIL, right? It's two binomials multiplied, so I'm going to have to distribute. So x times x times negative 1. Sorry about that. All right, so you have that distribution. So that's going to become x squared minus x. And now distribute the 2. So let me use green here. 2 times x and 2 times negative 1. That's going to be positive 2x minus 2. And then just simplify, and you're good. So this will become x squared plus x minus 2 over 3x squared. And this would be your answer. So I know it looks kind of tough in the very beginning when they have compound fractions. That's what they're called, fractions dividing fractions. It doesn't always have to be two fractions. Sometimes it could be a fraction divided by a number or a number divided by a fraction, but it usually has a fraction within the fraction. So anything like that, you want to rewrite it in like a straight line and then change it to multiplication, flip your second fraction, and then just multiply straight across and simplify at the very end. So these aren't meant to be hard problems, but they look difficult. Okay, they look difficult. And if I remember correctly, I think on the test there is some cancellation that occurs. So it becomes a little bit easier than what we even did. Okay? Any questions on 34? 35. So remember, this looks like it's supposed to be a hard problem. Normally they are. Usually when, even as a teacher, when I see these, I'm like, ugh. Right? Because now I gotta find the least common denominator. What's that going to be? But the nice thing about these problems is that the denominators are identical. If they are the same, then that means you don't have to do anything to the problems other than just combine the numerators. Okay? So my first step is to say n plus 1 minus 3n minus 2. Okay, notice I'm distributing the negative. Okay, I'm distributing that negative. On the bottom, it's still going to be 2n minus 1. Because the bottoms stay the same. Right? Think about it. Whenever you would do like 3/7 plus 2/7, your answer was 5/7. Right? The denominator doesn't change when they're the same. When they're different, the denominator changes. But when the denominators are the same, it doesn't change at all. Just the numerator does. Right? So, get rid of that. So let's just combine n minus 3n. That's negative 2n. Okay? And then 1 minus 2 is negative 1. Now, this is a little tricky. Okay? Can I cancel out the 2n minus 1? No, I can't. And you might say, but it looks identical. Well, the only way I can do it, don't write this down, okay? But look, pay attention. The only way I could do it is if I factor out the negative from the top. But notice how it changes the problem. It's no longer matching. If I factor out the negative, the minus 1 becomes a plus 1. Now they don't match. So that means I can't cancel it. Okay? Just because things look the same doesn't mean they are. Sometimes when you take out a negative, it changes everything. Okay? So with that, we're just going to leave it alone. And I know some people tell me, well, how do I know if I should try to cancel or not? Remember, you guys have multiple choices, right? If this is one of the multiple choice answers, then choose it. And you're done. You don't have to do any more. Okay? So look at your options and see whether or not you should stop. The next problem is the same thing. Okay? We're going to simplify 2x plus 2 over 4x squared plus 3x plus 5x minus 1 over 4x squared plus 3x. But these are the same. So since this is the same, then you don't have to find any kind of LCD. You're just going to combine the tops. Okay? Remember, you do have to distribute the positive, but whenever you distribute a positive, it doesn't change anything. They all keep the same signs. So this will be 2x plus 2 plus 5x minus 1 over 4x squared plus 3x. And then combine your like terms. 2x plus 5x is 7x. 2 minus 1 is positive 1 over 4x squared plus 3x. And there's your answer. Again, not supposed to be difficult. They look a little difficult, right? Because it looks really busy and all that stuff. But it's not meant to be difficult. If anything, it's just there to psych you out, to kind of make you worry, like, whoa, these are one of those hard problems, right? But in reality, they're okay. Just remember, same denominator, that makes it easier. Different denominator, those are the ones that can sometimes become nightmares. So we're thankful that they are the same denominator. Any questions on that one? All right, we got 4 more to go, 37, 38, 39, and 40. So this is the one that I think is the toughest one out of all of them, because we are going to have to factor things out and stuff like that. So they want us to simplify a fraction divided by a fraction. But remember, we don't want to divide fractions. We want to multiply by reciprocals. Okay? As I do that, though, I do want to factor as much as possible. So look at the top left corner, the 2x plus 10. What can I factor from that? A 2. So this will become 2 times x plus 5 over 2 times. Now, if I flip the second fraction on top, it's just going to be x plus 2. I can't do anything with that, okay? But the x squared plus 6x plus 5, I can do, well, at least I think I can. I can do the x method on it. So this is my a, b, c. So a times c, that's 5, and my b term is 6. Two numbers that multiply to 5 that add up to 6. Well, you only got 2 options, right? You can only use 1 and 5. There's no other, well, there are other multiples that give you 5, but in terms of integers, those are the only ones we can use. So that means that this thing factors into x plus 1, x plus 5. So let me put that right here. X plus 1, x plus 5. Can I cancel anything? X plus 5s, anything else? I hear you, the 2's, right? The 2's are gone. So all that's left is, on the left side, it's just 1 over 1. On the right side, it's just x plus 2 over x plus 1. Okay, so now that I have that, just multiply across, but 1 doesn't change anything, so your answer will be x plus 2 over x plus 1. Do you have any questions on this one? We get out of here at 42, so we're good. We got 10 minutes for 3 problems, and they're not too bad, so. All right, 38. Notice the nice thing about 38, it's pre-factored. So we don't have to worry about doing any factoring. Okay? All we got to worry about is what do they have in common? What can I cancel out? Okay, so go ahead and write that down. I'll give you a couple more seconds here. Yeah, I love doing these. These are easy. I don't have to do extra work. Just find what's in common, right? Cross multiply or cross cancel. I'm sorry, and we're good. So what can I cancel out? The 3D. Okay. What else? All right. Anything else? No, right? We're good. So the top is 1 over d minus 1 times 4 over 1. Remember, you just multiply straight across. 1 times 4 is 4. D minus 1 times 1 is d minus 1. And there's your answer. I always talk to you guys about my daughter. She gets scared when she sees stuff like this. She's like, oh, I tell her, just take your time. Most of these problems are not meant to be killers. You're not taking calculus, you're taking algebra. That's what this is, right? Algebra 2. I'm like, you're not in the calculus stage here. You're in the algebra stage. So they're not meant to break you, right? Calculus, yeah, sometimes kids cry. It happens, right? And we have to kind of help them get away from that. But you know, here it should be okay. It should be okay. All right. So it starts to get a little easier, right? 2 over 4x times 10 over 3. Now, some people like to multiply straight across and then reduce. Okay, I like to reduce because that makes my multiplication easier. Okay, and that's completely up to you, whatever you prefer to do. What would you guys like me to do? Multiply or reduce? Someone tell me. Multiply. I heard someone say multiply. So let's multiply straight across. So 2 times 10 is 20. 4x times 3 is 12x. All right, good. I'm done, but I got to reduce. What number reduces 20 and 12? A 2 does, but a 4 does even better, right? There's nothing wrong with the 2. It will reduce it, but you're going to have to reduce it again. But if you do a 4, you only got to reduce it once. So 20 divided by 4, that's 5. And 12 divided by 4 is 3. So here's your answer, 5 over 3x. Again, there's nothing wrong with dividing it by 2. Just make sure you check again and ask yourself, have I gone as much as I can? Because you would have to divide by 2 one more time. Okay? That's why the word simplify means do a step and then check if that step is done. If it's not, do more work. And then the next step, if it's not done, keep going. Keep going until you cannot go anymore. Okay? All right, last question. Solve the equation. Remember, we did a problem like this on day 1, but day 1's problem was a little bit harder. Okay, this one's a little bit easier. Okay? On day 1's problem, I think we had square roots on both sides, if I'm correct. Okay? This one just one side. How do you get rid of a square root? All right, so hold on. Square root. What did you guys say? Multiply? Divide it, not division. Square it. Yeah, we want to square it. Square a square root. And then to get rid of a power of 2 or a square power, you square root it. Right? It's just the opposite. So 5 squared is 25. The square root of 2x plus 3 squared is just 2x plus 3. And now just solve this, and this shouldn't be too bad, right? It's just a 2-step equation from Algebra 1. Subtract 3. That gives you 22 equal to 2x. And then divide by 2. You get 11 equal to x. And there are all 10 problems.